Hi everyone, and welcome to the fourth week. That's fourth week session 2 of our Cairo Bootcamp. So on Tuesday we had Nathaniel show everyone how to install different developer tools on Starknet, which he highlighted Scarp, Stackly, and also Starknet DevNet and Starknet Foundry and a lot others. So if you have issues looking at these tools or maybe installing them, you should have a look at the last session um solve your issues. Then if you have further problems, you can go on Telegram, ask questions, and also. But then today we'll handle hands-on ERC-20 token. Basically, Nathaniel is going to show you how to write ERC-20 contracts on Starknet and as well do other stuff. So I would allow Nathaniel to put you through on all this. Nathaniel? Hi, Nathaniel. Okay.
Okay, can you hear me? Yeah,
Yeah.
Jam, it's so good to be here again. I want to believe that our day is going well with us. All right, let's head on to the business of today. Okay, sec. Let me edit this. Okay, can you see my screen? Can you see my screen?
Yeah.
All right, so we're going to continue with um our teaching for today. We're going to be looking at hands-on ERC-20 token contracts. But before we press further, I want to believe that we have Scarp installed, we have Stackline installed, and we know at least how to initialize a project with Foundry, because basically that's what we are going to be using with this class for today. All right, so yeah, I've introduced myself already. So this is the agenda for today. We're going to be understanding what exactly is ERC-20. What exactly does ERC-20 means? Is it just is it just a bunch of numbers or what? What exactly does it mean? And then we're going to be looking at creating an ERC-20 token contract on Starknet and simulating transactions and interactions. We'll see all of these things. All right. So what exactly is ERC-20? I'm doing this as though this is our first time of hearing it. Let me not assume that everybody is exposed to the developer environment, but this is for those who are coming in for the first time. So what exactly is ERC-20? Think of ERC-20 like the rules for making your own money inside a video game or on the internet. So on the blockchain, we have certain rules and regulation that helps us coordinate how our money operates. There's a rules and regulation, the modus operandi with which our tokens must abide by. And the rules and regulation that every token on the blockchain must abide by is called the ERC-20. So imagine you're playing a multiplayer game and you want to create a new type of coin. Let's call it gamer coin, right? So you have a game, and what you do in that game is that you generate coins. Now, but for gamer coin to work well with other games, apps, or exchanges, you need to follow a standard set of rules. That's exactly what ERC-20 is. It's a rule book on how to build coins called tokens that everyone can understand and use. So from the little text here, for your game, that is a gamer coin to interact with other applications on the blockchain, what we basically do when we interact with other applications on the blockchain, we call it decentralized applications. What we use to do that transaction, that communication, is actually tokens. So imagine that you, as a game developer, you can only use your token on your game. You can't use it somewhere else. There's going to be a problem. So for your game to communicate with other games, you need to have something that binds you together. So what binds you together, we call it token. And for that token to be compatible with my game and your game, it has to follow the same rules, the same regulation. And the rules and regulation that our game must follow is ERC-20. Can you hear me? I don't know if you can hear me. Okay. Can you hear me? Am I being hard? I don't know. Check my chat. Can you hear me? Can you hear me? Guys, can you hear me? Just want to confirm. Okay, okay. Ebube, just want to confirm this. All right, just give me a second. I'm trying to fix up something. Cool, cool. I want to ensure everybody is following. Okay, let me share my screen. All right. Okay, so for your game to communicate with another application, it has to the token must have a common rule and regulation that keeps them together. So on the blockchain, what makes tokens to communicate with different decentralized application is because all the tokens are actually compatible with the ERC-20 token standard. Yeah. So why do we need ERC-20? If you make a coin without rules, other apps would not know how to check your balance, how to send coins to someone, or how to let someone else spend your coin. So imagine, like the previous example I gave. Imagine you have an application that you build from up scratch, from the bottom to the top. You have your own application, and your application has its own token, or let's say a protocol. You have your own protocol that has its own token, and that token can only be spent on your protocol. There's going to be a problem. There are other decentralized applications who want to communicate with your protocol. But for those other applications to communicate with your protocol, the token must have something that is common between your protocol and the decentralized application. So every token that is compatible with each other when it comes to spending, they all follow this ERC-20 token standard. So you notice that there are other tokens that you find it difficult to you can't spend stack on Solana chain. You can't do that. You can't do that because it's not compatible. For you to spend Solana on the Starknet blockchain, you have to do a swapping. You have to ensure that that Solana is converted into a token that is compatible with the ERC standard token, the ERC-20 standard of Starknet. Yeah, so basically that's what we're going to be looking at. So knowing fully well that the ERC-20 token, yeah, ERC-20 is actually a rule and a regulation for tokens. Now, what are the rules that the ERC-20 token is expecting every token to comply by? So what we call those rules are basically functions. So if you are having an ERC-20 token, it is expected that your ERC-20 token should have a name function. Your ERC-20 token should have a name function in it. So you cannot have a token that does not have a name. I mean, what do you want us to call your token? The token should have a name, and your token should also have a symbol. Starknet has a symbol, STRK. This is Starknet symbol. The token must have a decimal fraction. How can we split it? 0.001 total supply. Sometimes you hear tokens like the total circulation, the total amount of coin in circulation. You hear 1 billion tokens. You'll be like, my goodness, what's that? Some other tokens you hear 5 million. So it varies. It varies. So all of these things are the rules and regulations that every ERC-20 token must comply by. And the ERC-20 token must also have a function that you can check balance. I want to know if a person has this ERC-20 token in his wallet address. So that token should be compatible with this function. You should also be able to transfer your ERC-20 token. Your ERC-20 token should also be able to, you should be able to approve. Let someone else spend your coin. Like the previous example I gave. Imagine you can only spend your token on your protocol alone. Nobody can interact with your protocol, nothing like that. Nothing like that. It becomes difficult. It becomes difficult. So many coins, many tokens we have today, they are all compatible. They are all derivative of the ERC-20 token standards. They are all derivatives of the ERC-20 token standard. So if we're going to be writing an ERC-20 token, what we are going to be checking is we are going to ensure that our contracts has the name function, the symbol function, the decimal, the total supply, the balance of, transfer, approve, and there are many of them out there. There are many functions in the ERC-20 token standard. So the more we look at them, you discover that, yeah, it's something that we can work with. So moving on, do you have any question regarding the ERC-20 token before we start? This is just a quick introduction regarding the whole idea of the ERC-20 token. Do you have any question regarding the ERC-20 token? I don't know why I'm not seeing my chat. I don't know, is it the way I share my screen or something? Uh, I don't know. I don't know why I'm not seeing my screen. Okay.
Nathaniel, move to another screen. You should be able to see it.
Okay. I'm still finding it difficult. Let me see. Okay. Thing is the way I'm sharing my screen. All right. Let's see. Please, if you have any question, just feel free. Excuse me, you can unmute, just talk, and we can mute back because of our time. All right. Okay, so we're going to be having an ERC-20 token now. The first thing you need to do is to open your terminal. You open your terminal. All right. So by now we should know how to initialize a project, scarp new, and let's call it ERC-20. We're using Starknet Foundry, and we're good to go. So the next thing to do is to open it up, ERC. Okay. All right. Okay. I will suggest you follow me along so that we can make progress. You have a contract by default, you can delete it. You can delete it. You notice there's a configuration in the foundry.toml file by default. We will do a little. All right. So for we to have an ERC-20 contract, there are several ways of doing that. I'll just show you that because of the simulation and interaction that we'll be using. So I'll be using the Open Zeppelin ERC-20 contract. I'm very much aware that we've spoken about libraries already. You know how to add libraries. So this is Open Zeppelin token. You come up here, and then this is your Open Zeppelin. You can come copy this guy here. This is just to install the dependency. All right. The next thing to do is you can go to your GitHub. There's a GitHub link just below below the scarp art Open Zeppelin. So you come down here. So this is a template of this is an implementation of an Open Zeppelin. I said Open Zeppelin, an ERC-20 token contract. This is an implementation by the Open Zeppelin team. It has all the function that every ERC-20 token contract should have because of this ERC-20 mix implementation. So you copy this guy here. Are you seeing this? You copy and then you paste. So in this contract, we have remember what we said regarding the ERC-20 token. We said every ERC-20 token must have a name function, a symbol function, a decimal function, or rather, let's go to their their document just so that we can see it for ourselves. All right, so this is the documentation for Open Zeppelin. They have an implementation of the ERC-20 token. You can see it here. If you want to see the interface means that's the functions that are in the contract. You can just come here. So you can see the list of functions that are expected to be in an ERC-20 token contract. The total supply, balance of, allowance, transfer from, approval. So all of these are actually the interface functions that are expected to be found in the ERC-20 contract. So this implementation that we have here, although it seems as though the functions are not listed out here, but is the concept of components. I believe more emphasis will be made tomorrow. Components are already made codes. You don't need to be writing codes yourself. They are written already, yours is just to make use of them. So this contract you're seeing actually have all the functions that you'll be needing. And when we get to the simulation and the interaction, you'll be seeing how we can be calling these functions from our terminal just to be testing them to see how they will function in the real world. Yeah, so I guess you can remove this. You can remove this. You can change the name. You can give it any name you want. Maybe I'll call it my card. Sorry, I'm not very good at giving names. My card. Yeah, my card. And then there's a constructor. In our last class, we spoke about deploying a smart contract, and we deployed a smart contract without a constructor. But this time around, we're going to deploy the smart contract because for it to actually simulate or interact with it, we have to deploy it first. So the deployment is going to have a little addition to it. It's going to have some arguments attached to it because there's a constructor in our smart contract, and we'll see the logic. So the next thing to do is this is our constructor function. This is our constructor. Initial supply and the recipient. That's an address, but we can change this name to my card, and then the symbol. Maybe you can make it MC. Just make sure you are following me. Make sure you are following me. The initial supply we can make it fixed. We can make it fixed. We can make it fixed. We can make the initial supply fixed. Let's say the amount of token that we want for circulation should be this amount. Yeah. Okay, I'm making a mistake. And this. All right, so we have the constructor. So what this does is it takes the name and the symbol initialized from the ERC-20. This is a component from the component. Yeah, and then we get the it takes the name and the symbol, and then for the mint function, it takes the recipient address and the initial supply. Yeah. So this is just a basic of it. The next thing to do is to scrap build. You know what happened when you scrap build? We have a target folder that will be generated for deployment. And that will also make our library sync, the OpenZeppelin library we added using scrap add. Okay. I want to see. I don't know why I can't see. Still deploying. Still deploying. Okay. Let's look at this. Let's look at this function before it finishes. Okay. So this is an ERC-20 from OpenZeppelin. This is an ERC-20 from OpenZeppelin. This is the interface. We have the total supply, the balance of allowance transfer. So these functions are actually the rules that every token that must be compatible to an ERC-20 to ERC-20 token must have. The functions are actually the rules. So when we say you are writing or you are trying to have a token that is ERC-20 compatible, these are the functions that we are expecting to see. We should be able to spend it. We should be able to send it to some other people. We should be able to transfer. We should be able to approve. We should have a name, symbol, decimal. So all of these things here are the rules and the regulations. They are functions. Okay, yeah, we're good to go. So the next thing to do is to deploy this contract. And from what we said in our last classes, let's see. All right. So in our last classes, we were able to deploy a contract using Starknet, Signer, right? We're doing this from the scratch just so that we can continue to follow along. Please make sure you're following. So we're deploying this contract on our local chain. That's DevNet. So I think the next thing to do is to make our DevNet running. Let me separate this so that, okay. So we have Starknet, DevNet. I want to believe that we have Starknet DevNet installed. If you don't have, it's going to be a bit difficult for you to follow along. But please make sure you have Starknet DevNet installed, a local testing environment for Starknet contracts. So it has a list of accounts, the private key and the public key. They are pre-deployed. So we don't need to deploy the accounts the way we used to. These ones, they are already pre-deployed. So we starkly sign, and you can define where you want your output to be. You can actually create a folder that is separate from your working environment. But we've actually begun a pattern, so let's press forward so that those who are actually coming from the previous class can have something to go along with. So let's call it count.json. So it's requesting I'm making a mistake, the JSON file. All right, enter private key. So I come to this account. Okay, private key. Come to my private key, and then I paste this back here. Create an account. All right. So we can see an account.json file generated. The next thing to do is to fetch the wallet address and to create a store for it. Oh, I think I made a mistake. I'm actually supposed to name this file key store. I don't know if we can name it here. Let me see. Just bear with me for easy understanding sake. It's important I rename this account. Key store. All right. So the next thing to do is Starknet account fetch. So we're going to pick in the account address, copy it here, you paste, and your RPC. So the RPC we're using now, initially in the previous class, we used Alchemy RPC, but because we're using our local testnet, we're going to be using the this that is provided by the testnet, HTTP, and you paste this guy here. And you decide the name of the outputs. Let's call it account.json. All right, so we have the keystone value and the account. Oh, I made a mistake again. I'm supposed to put a full stop and put in a comma. These are some of the things. Okay. So you can as well just come here and delete this. All right, so we're able to get our private key from Starknet DevNet, and then put the information that are necessary into our keystone.json file, and we're able to get the account, the contract address, and store the required information here, right? Deploy the contract and the account is deployed already. All right, so moving next, the next thing to do is to declare Starknet declare. You come to your target folder and you copy this, copy relative path. You paste this here, and then our RPC. We have an RPC already. Let's just copy it from here. Paste, and it will expect us to add our account, and we have the name of the account already as account.json, and it will expect us to add a key store, and we have a key store as keystore.json, and then we enter. Awesome. So we have our contract declared on the local testnet. The next thing to do is to deploy Starknet deploy. You get the hash, the class hash, okay? And then your RPC, you copy this from here. I think literally everything here needs to be copied. Yes, this is it. Yeah. So to deploy, this is the deploy, our class hash and our RPC, our window to the local testnet, the account for signing the transaction that we're doing now, and we click enter. Okay, something is wrong. I made a mistake. The contract will be deployed. Okay. This is class hash. This transaction. Okay. This is the transaction. This is what I copied, right? Okay, let me see. I guess, let me see. So expecting, okay. Not really. The problem is not from the class hash. Remember, there's an argument. There's an argument. I'm leaving. I forgot about that. So Starknet deploy. Okay, Starknet deploy. Right? Starknet deploy the class hash. And the next thing to do is knowing fully well that there is an argument in the contract. It's important we make provision to that. So the arguments are from the constructor level that is expected to be fed with is a contract address of the recipient. So what we're going to be doing is we are going to be getting the recipient address from our account here. Account address, you copy it here and you paste. And then we hit. And we are good to go. Okay, so we have an ERC-20 token smart contracts deployed on DevNet. So what is expected from us now is to begin to simulate and interact with these contracts. So let's move back to the slide just so that we can see what's happening. So I hope that you're seeing my screen. Let me rush back to my, I don't know why my is like this, just to make sure that everybody is following. I'm at your terminal now. I'm at the message. Is there any question? Let me see. Okay, Ricardo, you have any question? Okay, I thought we were going to write it from scratch. Okay, yeah, we can actually do that, but I'm actually using the Open Zeppelin as a library. All the functions that we need, all the functions that we need are inside of the Open Zeppelin library. So what we're going to be doing is we're going to be simulating the functions from it just to see how they work. Yeah. Yes, cap add Open Zeppelin is not working for me. Do I need to add something? Why is it working? What's the error? What was the okay? Open Zeppelin token caused by do you have okay. You know what? Check if your SCAP is still intact. Were you able to initialize a project? Ricardo, were you able to initialize a project? Okay. Go to the let me see. Let me share you a link. I'm sharing a link with you. Okay, let me share the link with you now. Yes. I'm not sharing my screen at the moment. I want to see the chart. Don't know why it does that. Can you run through the deployment again? Oh, I'm so sorry, guys. I'm so sorry. So this is the link to, let me share my screen again. Yeah, you should see my screen now. Okay. Okay, for the deployment, for the deployment part, initially we were deploying our smart contract without argument, right? So the command we used to run during deploying our smart contract is stackline deploy, and then the class hash. And straight to the point, you supply your ERC, and then after that, you use your account for signing and key store, right? But this time around, we're going to be using arguments based on the ERC-20 contract we're using from OpenZeppelin. OpenZeppelin, the contract takes in an argument from the constructor level. So every argument that is to be fed in the constructor are fed from the deployment level. If you want to deploy a smart contract and you have a constructor, the first thing you need to do with the deployment is to ensure that you provide the necessary information that your constructor is needing. So from our contract here, our constructor is needing a recipient address, the address of the person who is to own these guys. So we use this contract's account address as the argument, and we paste it here. We paste it here. So this is the class hash, and then this is the argument. I don't know why I can't see it from here. Once the plane work with SCAP version, if you have previous version, it will fail. Okay, awesome. Someone is helping there. Yeah, so what's the question now? Where are we stranded? Just let me know so that we can continue from there. Is there any question? Are we on the same page? Okay. I got the code from the GitHub, from the OpenZeppelin GitHub from here. So on the scarps.xyz, beneath it, okay, just here, you click your GitHub and link to the GitHub OpenZeppelin, and you scroll down. This is just a best version of the OpenZeppelin. It has the library. So what this basically is showing us is it initializes the token by taking the name and the symbol, and then it mints it using the recipient's contract address and the initial supply. But because of the library of the OpenZeppelin, all other functions are implemented. And we saw the functions from the GitHub repo. We saw the functions from the docs, sorry. There's someone with question. Okay, thank you, Collins, for sharing that. Thank you. Yes, the code, like I was saying, I said I showed you the code. Let me copy this. Let me copy this page. This is the GitHub. And then this is the code I got. We copy it from here. Yeah. Can you see my screen? I believe you should see the screen. And then you come to your project, you paste it. But from the constructor level, the only adjustment we did here is to remove the package from here. We just remove this guy, this default configuration. And we made it such that our initial supply is fixed. This is the amount of the token in circulation, the initial supply. So are we on the same page here now? Yes. Yes, Cecilia. Yes, this is the contract. This is the contract. I want to show you an amazing thing about how to actually simulate, because as you continue to write more advanced smart contract. This is just so that you understand how to simulate your smart contract using basic ERC-20 smart contracts. For subsequent, I believe that more insight will be given to you regarding that. Yeah. Do you have any question? Where are you having issues? Just let me know so that we can continue from there. If you have any question, just let me know. If we're on the same page, just let me know on the comment so that we can continue. We're on the same page, just let me know. Okay, someone is saying something here. No change had to be made. Failed to look up for Open Zeppelin token. What's this? I'm getting the above error. What did you, what? Okay. Okay, I guess should be the, let me see. Okay. But has anybody successfully added his Open Zeppelin library using scarp add? Let me know if this error is unique. Okay, how did I add? Okay, Collins, you've done that. Okay, Hamed, awesome. Okay, someone is asking how did you write initial supply? Okay, so this is how the contract was before. Let me comment this so that we can do this together. So this was how the contract was. So I deleted this default configuration. We don't need it. Okay. Right. So the next thing I did was I changed the name. I changed the name of the contract to my card. You can give it any name you want. I'm just not very good at giving names. Side issues with version compatibility. That's Collins. What issues? Okay, let me be done with this. So I got this my card and then paste it in the constructor. There's a place for name which is coming by default. The name of my token and then the symbol for my token. The symbol for my token will be MC in capital letter MC. And then what I did is initially, if I'm to leave this constructor like this, it takes initial supply from deployment level and then recipient that's contract address. So what I did is I made the initial supply very fixed. It's not something that I'll have to constantly indicate while deploying my contract. So what I did is I removed the initial supply from the constructor level and then um I supplied it here. I made it fixed. Yeah, that was how we got to edit it. Okay, had issues with version compatibility. I resolved it so, okay, I resolved it so ASD installs cap. Okay, so what's the current issue now? Yeah, you're welcome, Kiki Crypt. And you've already installed. Yeah, so the issue is you need to have Open Zeppelin installed. If you need to have Open Zeppelin installed, you need to see it here. Just open your Scarp terminal. I know you were taught this. Just open your Open Zeppelin token to confirm that you have your Open Zeppelin library installed. Collins, no issue now. All right, cool. Do you have anybody with any issue before we press further? Are we good to go? Just indicate so that I'll be aware. Oh my, you don't have Starknet definitely installed? Whoa, what's this command? Let me see. What's this command? Let me find the command. Cargo install. I think it should be cargo install. Those of you who don't have cargo install, let me get the command for installing this. Okay. Okay. Okay, installed now. That's Mitch. You have it installed. Okay, installing now. Awesome, awesome, awesome. I think we've done that already. You can quickly rush back and pause so that we go into and fro. All right, are we on the same page, guys? Are we on the same page? Are we good to go? Just let me know so that we can continue from there. Please let me know. According to CP, yes, she mentioned that every smart contract must have an interface, storage, and implementation of the contract. Is there a reason why there is no interface in smart contract? Okay, yeah. So when she was explaining this, she did not explain, or rather, I believe the concept of open Zeppelin dependencies components. So what components are is that they are a combination of codes. You don't need to be writing these things. I showed us this from the documentations already. The Open Zeppelin library, it has the interface and it has the functions required. So this is just the foundation for every ERC-20 token contract. So every ERC-20 token contract or every contract, like you said, like Cindy said, which is very, very true, must have an interface. That interface is actually telling us that these are the functions that are inside of our contract. So the reason why you don't see this is because we are using a library. We're using Open Zeppelin library, and we stated it here. Let me rush back to this. It's not something that should confuse you. It's not something that should confuse you. Let me open this. Okay, so this is, excuse me. All right, this is Open Zeppelin. This is ERC-20. Yeah, so this is an ERC-20. Can you see the interface here? So if we are to write this contract, we are to write the total supply, the balance of, the allowance, transfer from, approved, name, symbol, decimals. But what I want to show you more is how to interact with functions in contracts. Whether you are using a library or you're not using a library, what is much more important is for you to actually simulate and do a transaction with your functions before sending it out to the main network. Yeah. So we have the interface, these are the functions, and then this is actually the implementation of the interface we've seen above. We have the name, the symbol, and so forth. Are we getting this? Um, do you have any question with that? Okay, because the functions are already what? What's this? How am I seeing this? Oh my. Yes, Mitch. Because the functions are already defined. That's one of the good thing of using components. They are a group of functions. It's like you want to somebody will tell you do not reinvent the wheel. It's just make your life very easy. The functions are already implemented already. You don't need to start writing the whole functions when there's a whole library for that. There's a whole library that is this work. We don't need to start writing all the functions from one, and then we start, yeah. So because this is the tutorial, you can actually do excuse me, you can actually do an experiment. You can actually try to write these functions line by line, trying to see how you can go around it. But for the sake of this class, what we want to primarily achieve is to have um at least a template of an ERC-20 token contract and then simulate it So all the functions that are in an ERC-20 token contract, we can actually interact with them. This is what we'll be showing after now. But I want to be sure that we are all on the same page. That so far we have our contract written this way. If there's anybody who is having any issue up until now, you can do so to let us know so that we can help you. Training messages. Why do I keep? What do I keep? Are we good to go, guys? Just let me know so that we can continue. Are we good to go? I want to be sure we're on the same page. I'm actually looking at the chat. Just drop a message so that I'll be aware that we are on the same page. Okay, Ahmed. Thank you. Thank you. Thank you. Thank you for that. All right. So I'll be checking my chat intermittently just to carry everybody along. So we're able to use the command stackline deploy, excuse me, stackline deploy, the clash hash, and then the contract address from our Starknet DevNet, and we indicate our RPC and account and the key stuff for signing. All right, so what is next now is for we to begin to simulate these transactions. There are functions in this contract that we want to check if they are actually working fine. This is the number of token that we are having as initial supply. This is the name of our token. This is the symbol. So we want to be testing all of these functions. Let's run back to the slide and let's see what's next. I've seen a little demo about it. So simulating transactions and interaction. On Starknet, simulating transaction and interaction refers to the process of testing or previewing how a transaction would behave on chain without actually sending it to the network. So for instance, now that smart contract I wrote is actually my token. I truly want to have it. I truly want to have a token deployed live. So I can actually begin to test how these things will work on live chain, even without sending it to live chain, knowing fully well that we have testnet. Even before deploying, we can actually deploy it on testnet and then simulate to see how it happens, but we're using our local chain to do that. Okay, someone is having a question. I'm checking my chat. The interface is so that we can call the contract with a dispatch. I'm not sure it once we do that. Okay, if we press further, you'll see what I mean. It's just because we've not started simulating and calling our functions. When we get there, you understand more better. Once you, yeah, just be patient. Just be patient. I know that it's curiosity and I love that. Yeah, it's curiosity and I love that. Yeah, so we can actually see how functions need to work. The reason why you keep asking interface, the interface and the functions, like I can say, they are in the library. What we did is we imported the library and bring out what is needed to deploy our contract. We don't need to start rewriting these things that are presented to us as libraries. I don't know if that's clear. All right, so for we to simulate, to test, to preview how a transaction will work, there are certain commands that we can use. And the first command helps us to read on chain. So what we are able to achieve here is that we actually deployed this smart contract on chain. We deployed this smart contract on chain. And when I say on chain, I don't really mean a testnet. I just mean a local environment, your Starknet DevNet. We're able to deploy it on Starknet DevNet. But we want to see the interaction, how it would function in the real world. So there are functions, there are commands that we can use to see how these things work. And the first list of commands that we can use is the read-only command. The read-only command functions, that's the call function we have to get the name of the token, to get the symbol of the token, to get the decimal of the token, to get total supply, to get balance of an address. to check if an address has the token. We want to see how much of the token an address has. Get allowance. So all of these things you're seeing, this this name, this symbol you're seeing, this decimal, they are actually functions for every ERC-20 token. Let me go back and go forward so that we can understand. Remember what we said? We said ERC-20 tokens, they are standards for creating tokens on the blockchain. So for you to have a protocol that can relate with other decentralized applications fluently, compatibly, the token must have something in common. And what will make them common is because of these basic rules and regulations that all of them abide by. And the rules and regulation is what we call the ERC-20. That rules and regulation is not something that's written in a book that say, okay, thou shalt not do this. So the rules and the regulation are actually functions. So for we to say that a token must comply with an ERC-20 token standard, what we are saying is that we are expecting that token to have the basic function that every ERC-20 token should have, like the name function, the symbol function, the decimals function, the total supply, the balance of, the transfer, the approval, and many of them out there. And many of them. So that's the rule book we're talking about. That's the templates. That's the rules and regulation we're talking about. That this token must have this function compatible. So we used Open Zeppelin library because these functions are implemented. They are a library. You can use them on your project. There are moments where you can be working. Maybe let's say you're working maybe a DAO contract. You will not want to start saying you want to start you don't want to start saying you want to start writing a new contract, a new token. You can actually import your library and make use of it in your DAO. So it's very important you understand this, that libraries are of good significance when it comes to easing our work. But what I want to achieve with us in this session is how we can actually interact with these functions. So on this contract, the contract is linked with the library. We've added it to our work project already. We can actually call these functions to see their behaviors. We can call the function to see my card, to see the total supply, to see all of these things. You are actually simulating the blockchain. You are querying information from the blockchain. I want to know this about my contract. Is it really doing this thing I'm expecting it to do? Is my contract complying to the standard of the ERC-20 token? If it doesn't, then you can fall back to your code and say, no, I don't think I will use the Open Zeppelin library again. I want to do something else. So that's just the idea. You need to simulate, you need to test, you need to be checking the transaction to see if these things are working as they ought to. Yeah. So, and for we to simulate, we said there are basic functions, there are basic commands that helps us simulate and interact with our contract that are deployed on chain. Now, the chain I'm talking about is in the context of our Starknet DevNet. So there's a way we can interact with it via our SNcast, which is the call. So this call command is actually helping us to read data, to query data that are stored on the Starknet DevNet. Yeah. And then the next in line is we have the invoke function. So the invoke function is that function that helps us update states. Initially, we are seeing that. Now, this is just amazing. I mean, I don't know how you're seeing this, but it's just so amazing that you can actually run your functions to see if they are doing what they should do, to check if your function is actually returning the name of the token you saved. And this is not just something that is applicable for just ERC-20 token contract. You can actually simulate any contract you have to check your functions to see if they are working as they ought to. In addition to your test contracts, you can also write a test contract to be checking your function, a unit test or any kind of or integration test. But when it comes to simulating transaction and interaction, you are querying them. It's like I have deployed them. I deploy the contract. So I want to see if people can actually effectively interact with my contracts, if they can actually interact with my application. So that's the essence, that's the idea of the simulation transaction and interaction command. It's very important we know this. Are we clear on this? So the first we have is, based on what we've said, the first we have are functions that helps us read from our contract. The things that are stored on the chain. It helps us read what we were able to store on the chain. So for instance, the name of our contract, the name of our token, my card, is actually something that is stored on chain. So this simulation command helps us access the name of our contract, the name of our token on chain. And then this function that helps us, these functions, this symbol, it helps us get the symbol, the MC symbol. You're not expected, what we're expecting is, we won't be expecting to call this function, this symbol function. Don't worry, when we start to implement these things, you'll see the logic behind it. I know it's not very clear, but as we press for that, you'll see it from the terminal level. So when we call the command that helps us read the symbol, what we are expecting to see is MC based on what we deployed. Or when we call a function that the name function, what we want to see is the my card. So when I say my name and my symbol, sometimes it looks very confusing to some of you. And that's why I believe some of you are asking for interface. Let me rush back to this. Let me rush back to this. So I actually send this doc. Let me send this again. Let me send this again. Yes, I have Mitch. I've deployed. We've deployed already. Were you around when we deployed? We were able to deploy the contract on Starknet DevNet. Were you around when we did it? Okay. Do we have any questions so far, guys? So these are actually the functions. Are you seeing the name function? So this is the interface. What this interface is telling you is this is a list of all the functions that our library comes with. Our library comes with this function, this symbol, the decimal. That's why it's called library. I don't need to write this interface again in my code. They are libraries. They are there for my use. And everything here in my contract has every right to make use of everything that is here. Are you getting this, guys? So when we are querying our chain, we want to know the name of our token. The function we are calling is this function. So we want to check if our ERC-20 token is compatible with the name command, with the name rule. Like I told you initially, all these functions are the rules that every ERC-20 token must be compatible with. On chain, yeah, I have the context now. When I say on chain, I mean my Starknet, DevNet, just my local chain. Yeah, my local chain. It's a local environment. Here is it. This guy, this is it. With the RPC helped me access it. This guy here. Yeah, so that was what I meant. So if I want to see the name of my token, and I'm trying to query it, I want to see if the function is actually working fine. If that regulation, that rule is actually working as it ought to. This is actually the function I'm calling. I'm calling this function. And this function is meant to return a byte array, meaning it ought to return a name for me. I want to see a name. In our case, what we are expecting to see is a my card. Don't worry, if we start doing this thing more, you understand. But this is just it. And then for writing, so you now understand that in every smart contract, there are two basic fundamental kinds of functions. The two basic fundamental kinds of functions are the functions that write to states, and there are functions that read from state. So the command that helps us simulate the transaction we've seen in this slide is the one that helps us to read from state. And then the function that helps us to write, to update states is actually this command. These are the commands, the transfer commands, the transfer from commands, and the approve commands. Yes, we'll see all of these things. Let's see how far we can go with this. Do we have any questions, guys? I know there will be questions, but let's press a little bit. A little bit. So simulating an interaction demo, let's see it now. All right. Okay, give me a sec. Okay. Let me kill this. Let me open another terminal. Okay. Give me a sec. Let me bring up my docs. Okay. 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 So the first we have all right. We can check this guy out. So for reading from our state, the command that helps us do that is the sncast call command. So don't try to start breaking your head to understand what this is. From this command, you would understand. So we have the sncast call. The first thing the sncast call does is that it takes the contract address. You know, after deploying, we have a contract address, right? After deploying, this is our contract address. The contract will be deployed at address. This is it. The one that ends with 67F. So don't kill your terminal. Just ensure that your contract address is intact. Yeah. All right. So it takes our contract address. This is the space for our contract address, and then it takes an argument function. Now, this function must be the same with the ERC-20 standard. You see, if you want to check name, you cannot put names with S. It's not names, it's name. It has to be the same with the ERC-20 token standard. That's how to actually query to check, to simulate, to see if the function, the name function, is actually working fine. So what we want to achieve is we want to see the name of our contract, our token rather, sorry. And guess what we are expecting? We're actually expecting my card, right, guys? Yeah, so let's see how this will turn out to be. Okay. 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 All right. Okay, so we sncast call, right? So the next thing to do is you write this is your double flag contract and then address. So it's expecting an argument, the contract address you return here, and you get your contract address because this is actually the smart contract we are trying to simulate. You can't simulate an address you can't simulate a smart contract. You can't simulate a smart contract. You don't have the address. So you copy the address based on what is required by the command, paste here. And then what's next? You identify my function. So the function we want to check is the name function, right? Right, guys? The name function. We want to check the name function. So all we're going to be doing is identify this as name, right? Yeah, and then so for it to do what's next, we need to have access to the Starknet definite chain because you can't be querying something you don't have access to. And that's why we use our URL, right? Okay, yes, you're on track. And then we return here. our URL. You get this guy copied. Just make sure you're following along. Oh, what did I paste? And then HTTP, and we paste. Right? And then let's see what we get. All right, so we have an output. But here's the issue now. The output is in hex. We are not computers. I know there are some few persons on earth who can read hex. But I'm so sorry, I don't happen to be one of them yet. Or very soon. So this is actually returning it in a hex format. We want to know what exactly does this hex means? What's this? I hope you can see my screen. Let me zoom in. Oh, okay. All right. So we can actually feed AI with this hex to tell AI to convert readable. Let's see. Let's ask AI to help us. Um, let's ask AI to help us with that. And then you copy this command, and then you give me this in human readable. All right. Okay, someone has a question? Just hold on. All right, so ChatGPT was able to convert this hex, and we have the output my card. Are you seeing this? So we're able to actually simulate to check what is the name of this token. We're able to do it, and we are seeing that the name of the token is my card. So yeah, what's the question? It's the same question on my mind. Ha ha ha. People actually read hex. Absolutely, guy. Ah, people read hex, actually. People read hex. But there are very few on earth. And I hope to be one of them soon. Yeah. Yeah, and I know that there are devs amongst you guys who are reading hex. You're just hiding yourself. We'll fish you guys out. We'll soon fish you guys out. Those of you who are reading hex. All right, so we're able to check, and now we are seeing that this hex that we got is actually returning the name of our token. So it means that our our command is actually simulating well. We're actually interacting, we're actually fetching data from the chain to know what it is about our contract. Yeah, so the next thing we want to check is from this, we want to check the let's check the symbol, right? Yeah, let's check the symbol too, and then we check the initial supply. Let's check the symbol. Yeah, I hope you guys are trying. I hope you guys are following along with me. Are we on the same page, guys? Are we on the same page? Awesome, Hamed. Awesome, awesome, awesome. I'm loving this. Any other person? Is it just Hamed or awesome? I love that. Olojimi. Thank you. Thank you. Thank you. All right, let's press further. Let's press further. So let's the same command. You just go up, but this time around, this function is going to change. This function is not the name function. You want to get the symbol, right? And then you return to since this is a library, and our library is not physically implementing our interface to just know the exact name of the function that returns our symbol, you can always return just to confirm this is the name of the function. It has to be correct. I will try to fill in this just so that you will know something. This is actually it, right? Let me copy it. Oh, sorry about that. Let me fill the command so that, or rather, let me try it with this same name. This is the same command. I've not changed it, but let me add S to it. I've added S to it. That's not the name of the function that returns the name of my token is just name. Anything more than that or less than that will return an error. So let's test this out and see. It says requested entry point does not exist in the contract. Requested entry point does not exist in the contract. What that is telling you is, it's telling you, oh my boss, we can't find this contract. This thing is not compatible with the ERC-20 token standard. We don't know any rule like this. So you can't be checking this thing to know that your token is actually having a name function. It's wrong. It's wrong. Are you getting this? So it has to be correct. You have to give it the correct name. And here we go. So this time around, we want to check the symbol. We want to check for symbol. And then you paste for symbol. And boom, we have an hex. We can also convert it. You copy this guy and you return to AI and you tell AI, please help us convert these two. All right. Okay, so it's converting. Are you seeing this? It's telling us that the OX4D is actually M and the OX43 is actually C. OX4D and F3. So this, this X is just crazy. This is just mind blowing. I love this. So M and C, right? Yeah. And what's the name of our token? MC. Are we getting it? All right. I guess someone has a question or something. Let me see the chat. When I was exploring this, I was also asking myself the same question. I was thinking if it's not something that is implemented yet, I'll make it a project. You can make it a project. Amen. You can make it a project actually. Knowing fully well that not every dev can read. I don't know about that yet. Maybe it's possible and I'm not aware of. But with what I'm exposed to at the moment, I'm yet to see a method where it will return just the exact name. Maybe it's there, but I'm not aware. Maybe you can do a research on that. And if it doesn't exist, it would be nice for you to give us that. Abi, how do you see it? Amen. To be nice. To be nice. Yeah, it's a project already, bro. You can actually just do your research along, just find out, okay, is this thing possible? And then you return and you implement it. Yeah, that's the dev spirit, guys. Okay, do we have any question with what we've seen so far? Do we have any question? If there's no question, just tell me yes, or just tell me something. Are we on the same page so that we can work together? Are we following? Okay, awesome, awesome. Is it just Olojimi? Is it just Olojimi? Awesome, awesome. All right. I want to be sure and I need to be sure. All right, so the next thing we want to test is let's go to this contract and let's see the decimal. Let's see decimal. Let's see decimal, or let's see, see the things that I carved out. Let me work with plan, if not. Just give me a sec. Okay. Okay, so let's see the total supply. So based on what based on what, excuse me, based on what we have here, this is the amount of token that are in circulation. So let's see if that's true with our token. Let's see if our token is following that. So the function that helps us do that is the total supply function. You can be sure of that. You can return to your contract. to get the exact name of the function so that total supply. Are you seeing this? Total supply. This is it. Total supply. So we're going to use that now. Total supply. Should we do decimal now? Okay, yeah, let's try decimal before total supply. Let's try decimal. Okay. Yeah. Yes, I did back in. Yeah. Please share to the tab you are reading. Share to the tab. You mean I should share? What are you saying? I don't understand. Joseph. Joseph, can you make your question clear so that I can understand you? Okay. All right. So let's see the same thing to those functions that only read. There's nothing ambiguous about them. Just something very simple, straight to the point. You just check these things to know they are working fine and all of that. So total supply, right? Okay, decimal. I said decimals with the S. It's very important. Decimals. So decimals. All right, let's see the decimal. It returns an X for us, so it means it's working fine. Let's see the total supply with a cap of S, total supply. So the function here that you're inserting must be accurate. Total supply. Awesome. So let's check this guy. Total supply. I feel there should be a way where you can easily check these things not in hex form. Because if this is a way, then I guess we'll be wary trying to simulate a contract. So we're trying to check the total supply, and this is the exact amount we have here, 1 million, and this is what we have, 1 million. We've seen this, guys. Yes. Is there no UI built to interact with Starknet contracts? You have the URL, please share. Oh, we've shared this URL. Yes, you can help him out on the chat so that I won't be distracted. So those of you who are close to the link to the Starknet remix, you can help him out with it. But we spoke about it in the last class. You can do well to check it out. All right. So let's just compare this decimal. That's it. Let's compare this decimal. This two. Okay. 18. Are you seeing it, guys? Good to go. 18. Are you seeing it? It follows the ERC-20 standard. Yeah, so the next thing we want to do now from our slide is to begin to write. This is where it becomes more robust. Yeah. Okay, so now we want to do a simulation that does not just read. We want to actually mutate this thing, this state we are trying to write. And there's no better way of mutating a state other than transferring. If you are transferring, it means that your amount is reduced. Okay, before we do that, let's check the amount of token in our contract. You know, we actually assigned this contract, this address, sorry, I said contract. This is actually the address that has our token. So let's check if this guy has a balance off. Let's do the balance off function. I almost forgot. It's very important we do that too. Okay, balance of. Let's see. Okay, so excuse me. So the commands I'll be introducing now will be taking in some call datas. They'll be taking in some call datas, meaning we are taking in arguments. You're not just reading, but you are using something to read. Yeah, you're not just reading from the state here. Excuse me. Excuse me. Okay. Yeah. So we're um not just using functions to read what's on the chain lookout chain, but we're using an argument to read. So the first we want to explore is the balance of function. The balance of function. The reason why I'm doing this to compare with the ERC-20 token standard is just so that you know that these things we are doing, we are not just playing around. The balance of it takes in a contract address and returns the amount of token that this contract address has. So we're going to be doing that. So the previous simulation we did was just checking like names. You don't need to put any argument to them, symbols, decimals, total supply. They are not very complex. You don't need to put any argument to them. The only thing you just need to do is um, to just get the contract address and then the name of the function, which is the name, the symbol, the decimal. But for functions, that's the ERC-20 token standard that requires an argument to read from state. You have to provide a call data. I think we stated this on our slide. Yeah, okay, I think I didn't. Yes. For balance of, if you want to check a balance of, you need to provide a call data, the address you want to use to check the balance using your contracts. Yeah, so let's do that quickly. Let's do that quickly. All right, so this is what we're going to do. You make sure that the name is correct. Balance underscore of. Yes, I believe this is it. Sure. Balance of. And then this balance of will now take in a call data. A call data is taking in an argument. And the argument is the address we want to check. If we want to check the amount of token, our MC, the amount of MC in our contract, in our address, in an account, sorry. And the accounts we initialized while we are deploying as the recipient address, this is it, right, guys? If you remember. So let's check. Let's check. Yeah. Okay, so enter. Boom. I'm good to go. Let's compare to see the amount of token that are in. Whew. Somebody needs to help me. I need to know a better way of doing this. I need to. Okay, are you seeing this a million token? So it's correct. We've not done any transaction yet. Yeah, so it's well, let's try an address that we know it doesn't have this token. Let's delete this guy. Let's try. Let's use this. Let's use this. Okay. All right. Are you saying OXO, OXO? I know I don't know hex, but I know this one is zero. I know I don't know hex, but this one is zero. Am I right? Senior engineers and developers amongst us. OXO, OXO hex. Is it zero? Let me see. Let me see in the chat. My senior engineers, are we there? What do you think this X is? Is it 0? I think it is. Yeah, Chidera. It should. Yeah, it should. It should. Yeah, I know a little about EVM. So, but to those who are curious, yes, it is. Maybe okay. Let's confirm. Let's confirm these two. It should be 0 because that account doesn't have a token. Yeah, the result is 0. So those of you who stood with 0, you're right. OXO OXO is 0. Yeah, are we good to go? Yeah, there's one more allowance. Allowance, allowance. So all of these things are just ways simulating our contracts, simulating our contract. Yeah. So it's just amazing. Let's see allowance. This guy. Okay, spend. Okay, let's see allowance. Let's see how far this will go. Let's just test it and see. Allowance. Okay. Yeah, DK. This. Do we have any questions so far? Is there any question? Is there something that we're not clear of with this simulation? Is there something that we're not clear of? Do you have any question? Okay, yes, okay, you got lost. Oh my. So where exactly did we leave you? At what junction did we leave you, sir? Just a hint so that we can help you. What are we doing exactly? Okay, I got me. What we're trying to do is we have a smart contract. Excuse me, guys. We have an ERC-20 token contract. We used an Open Zeppelin library to have it. This is actually an ERC-20 token smart contract. We actually began by explaining what an ERC-20 token is. We said an ERC-20 is actually a standard for tokens. So for tokens to interact and be compatible in different decentralized applications, they all have to adhere to the same rules. And the rules that regulate the behavior of every token is the ERC-20. For NFTs, 721. We're not talking about NFT. We're only talking about ERC-20. Let me not start talking about something else. So the rules that guide the behavior of every token is the ERC-20 functions. The functions that are in an ERC-20 standard contract are actually the rules that every ERC-20 token must comply to. If you right now you have a project you're running and you don't want to use the token that is on chain by default, you want to have your own token. Maybe you want to you are building a DAO. You have a DAO, and what you want to use in your DAO is your own token in the DAO. You can actually write an ERC-20 token, create your own token, redesign it, reconfigure it, give it your own taste. And this is exactly what we did here. But what we did here is we did not deploy it on Sepolia testnet. We did not deploy it on mainnet. We deployed it on a local chain, which is Starknet DevNet chain, our local testnet on our computer, just so that we can simulate that transaction. So the same thing. This is not just something that is applicable to just ERC-20 tokens. It is applicable to any contract you can write. You can be it a crowdfunding contract, an auction contract, a Uniswap, any contract at all. You can actually do that. You can actually do that. But as we advance, you discover that there are ways of actually testing if your functions are working fine or not. We'll be seeing that hopefully next week. But what we are trying to do with simulations is we want to see the behavior of our token on chain. That's why the first thing we did was we declared and we deployed it on a local testnet, excuse me, which is Starknet DevNet. We deployed it on a local Starknet DevNet so that we want to see how this token will interact when it's deployed on a main chain. So what we are now doing is we are trying to check the rules and regulations. If our token is actually complying to the rules and regulations of an ERC-20 token. Are you getting it now? So the functions that are in an ERC-20 tokens are the rules and regulations that every token that is ERC-20 compatible must comply to. Yeah. So we've been using a series of commands. What are we? Okay. Yeah. So we'll be using a series of commands. So seeing this sncast call, which it takes in an argument a contract address. This is the contract address this is our contract address. When you deploy a smart contract, you get a contract address. So we take the contract address as an argument and a function that requires a name. So this name you're seeing is actually a function in a standard ERC-20 token contract. So this name is not just a function. We've stated it initially. We said these functions are actually the rules and a regulation that every ERC-20 token must comply to. It's strange for you to want to know a name of a token and you are not knowing the name. It's strange. It's strange for you to want to see the symbol of an ERC-20 token and you're not seeing the symbol. It's strange. It's strange for you not to know the total supply of a token. It's strange. It's strange for you not to know the balance of a token in your wallet. It's strange. So all of these things are rules and regulations that every token must comply to. So what we are doing now is we are simulating. We want to see its behavior on chain. Can we actually see what we are expecting when we deploy this token on chain? And so far, the response is positive. We've seen the behavior of calling the name function and is actually returning it in hex form. And like I said earlier on, I'm yet to actually understand a better way of returning it with a name, not not in a hex format. Maybe someone can help us with that. Or if it's yet to be invented, is a project I believe one of the senior engineers amongst us are finding interest to do. Yeah. So we also looked at the name. Yeah. We also saw that I'm just doing this for everybody so that we can understand and be on the same page because sometimes I may be fast. So we also saw that if you make a mistake with the function, regardless of the arguments, no matter how accurate they are, if the function does not correlate with the list of functions in an ERC-20 token standard, it will return fail. And that's why we got this failure. It says request entry point does not exist in the contract. That's what it's telling us. Because this function is not known in an ERC-20 token. It's not known. This function does not exist in the rules and regulation of an ERC-20 token standard. So we have to adjust it to suit the name. Are you getting this now? Yeah. And then we checked symbol and we got a hex version of it. We used AI to help us interpret it, and the feedback were positive. We saw the decimal, we saw the amount of total supply. We've seen all of these things together. We've seen these things. Yeah. So I hope you have an understanding of what we've been doing. God will. Does anybody have any question? This is just all it is about simulation. Checking these contracts, knowing how they react on chain and all of that. Do you have any question? Yes, I do. Thank you. Okay, yeah. Okay, thank you. Thank you. That's nice. Yeah, guys, do we have any question? So I want us to keep exploring. Are there other protocols other than ERC-20? ERC-20. Okay, so ERC-20 is for tokens. Like I made mention, we have we have ERC-721. That's for NFTs. These are for NFTs, and there are other dozens of them out there. So if you want to have an NFT, there's also a template for an NFT by default. But our focus, don't worry, as you keep advancing, you'll be seeing these things. I love the curiosity, guys. I love the curiosity. But what you need to understand is that when you have a contract, you can actually simulate that contract to know its behavior on chain. Yeah. So we use ERC-20 token contract to know the behavior of our token on chain. If we deploy this contract, how is it going to be doing on chain? And that's what we've been seeing so far. Yeah, that's what we have been seeing so far. So I don't know if anybody has any question again for me regarding this. Do you have any question? Excuse me. Sorry, my face is a bit dark right now. Do you have any questions for me? Okay, yeah, I guess that's it for my presentation, and yeah, I'll call it a day from my end. I don't know. Sarah, are you here? Mr. Paul. Can you guys hear me? I hope I'm not talking alone right now. Can you hear me? I believe I'm heard, right? Awesome, awesome, awesome. Thank you, Ebuka. Thank you, Ebuka. Yeah, thank you, guys. Thank you. So you can check this out. You can check this out. I'll share a link with you, guy, maybe after the class, just so that you see more of these commands and how to simulate a transaction on chain. I mean, this is very amazing. Yeah, thank you, Chidera. Yeah. The officials, are we here? Um, Please, if you have any question, just let me know, guys. Let me know. Let me know. If you have any question relating to what we spoke about, our session for today. If there's any question based on the session, anything that you're not clear of, you can let me know. Okay. Um,
Hi, Nathaniel.
yeah, I think I'm done, sir.
Okay, pretty much, pretty much. Thank you so much for
Yeah.
the class. Thank you so much for the class. And I hope everyone was able to grasp what Nathaniel thought from the first session and today's session as well. So just like we have been doing, we'll always keep on changing the gear from 1, 2, 3, 4, 5. And tomorrow we'll be on the fifth gear, which will have an amazing tutor. His name is Kaswini. I'm sure like some of you know him, but if you don't know him, he will intro himself very well next week. And the topic for next week is advanced Starknet contract development, and he will be exploring different topics like composability and components, which would also involve introduction of it on Starknet and also building modular contracts and a whole lot of other stuff, right? Which you would enjoy and learn in the next session. So today we had like compared to normal we used to have last week and other weeks. I encourage you to invite your friends that have been part of this bootcamp to always turn up, and because it's always essential to be part of the live session. I mean, there's no feeling than actually being able to get answers from your tutors, and next week's session is going to be amazing, just like this week as well. So if there's no further questions, we're going to call it a night. And the recording of this call of this class will be available tomorrow, as well as the assignments. And if you have not done assignment for week 3, kindly do it. And so we can, at the end of the day, make the most out of this bootcamp. But everyone is doing great, and see you next week. Good night.